So in the previous video, we have discussed the problems on convolution. In this video also, we are going to discuss the problems on convolution. But in case of convolution, we can do this or solve these problems using different methods based on the input which is given, or based on the sequence, or based on the question. You can also go with the graphical method or matrix method of doing solving the convolution is also possible. So in this video, we are going to discuss how we are actually going to convolute two different signals in case of the graphical method. Okay. So given that you have a question to determine the convolution of two different sequences, you are given with the sequence x of n, which is equal to 1, 4, 3, 2, and here you can see you have an arrowhead which is over here, which means this is going to be your origin point. So left side of your origin point will be your negative axis, and right side of your origin point will be your positive axis. Okay. So starting from here, at the time period n is equal to -1, the amplitude will be 1, and the time period when it is 0, the amplitude will be 4, and when the time period is 1, the amplitude will be 3, and the time period when it is 2, the amplitude will be 2. And here in case of h of n, we don't have any arrowhead. So you can start from 0, 1, 2 and 3. Okay. The first step is that you have to first analyze what is the given signal which you have. So by analyzing this sequence, you can say that the sequence x of n will start at n is equal to -1, and h of n will start at n is equal to n2 is equal to 0. And therefore, the starting point of analysis will be your -1. And in case of the convolution, we have to find what will be the final length of the sequence also, right? So in case of final length of the sequence, you have to just find the length of this sequence, which is 4, and the length of this sequence is also going to be 4. So the length of this sequence plus the length of this sequence -1 will be the final length of the sequence which I am going to provide. Okay, so 4 plus 4 will give you 8. So 8 minus 1 will be 7. So the final length of the sequence will be of the length 7. Okay, just remember that. Next, what we are going to do is we are going to express the given sequence as a graphical method. Added to it, what I'm going to do is I'm going to represent it with an index of k. Okay. So when I represent it with an index k, what happens is I represent it as x of k instead of x of n. As we have discussed earlier, at the time period we have this sequence which is x of n, which is equal to 1, 4, 3, 2. At the point 0, the amplitude of the signal is 4, and at the point of -1, the amplitude of the signal is 1, and at the point of time period 1, the amplitude is 3, and at time period 2, the amplitude will be equal to 2. Similar to that, I am also representing the signal h of k in terms of graphical method. Okay. Next, what I am going to do, I am just going to find the signal h of -k, because what happens is first I'll define the signal in case of graphical method. Next, I'll change the index part as k. After changing it, I'll just find the folded version of the signal, which is nothing but h of -k. So what happens here, this is going to be your h of k signal, and this is my h of -k. I'm just going to fold this signal. What happens after folding? This part will come here and this part will come here. That is what is happening here. Okay. So the zeroth signal the signal at 0 will remain at 0. Okay. So the signal at the time period 1 will get shifted to -1. The signal at time period 2 will get shifted to -2. The signal at time period 3 will get shifted to -3. I'm just folding this part of signal to this side. That's it. I'm not going to do anything much. Okay. So we just folded the signal. So actually what happens in case of convolution is I'll find the folded version of the signal. I'll time shift the signal once. and the number of times I used to time shift the signal. Once after shifting, I'll find what are the points at which the actual overlap occurs, and the time period at which the overlap occurs. I'm just going to multiply both of these signal, and finally I'm going to add those signals. This is what is going to happen here. Okay. So in case of formula, if I want to represent the signal, I can represent it as y of n, which is equal to summation k, that is equal to minus infinity to plus infinity, x of k into y of n minus k is my formula for convolution. So I'm going to substitute different values for n. Okay, since my signal x of n is starting at the point of minus 1, I'm going to start with the point of minus 1 here. If I substitute minus 1 here, what will happen? It will be y of minus 1, which is equal to summation of k, that is equal to minus infinity to plus infinity, x of k, h of minus 1 minus k. Okay, I'm just going to delay this signal minus 1 times. So what happens if I delay the signal minus 1 times? This part will shift to here minus 1 times. So minus 3 minus 1 will be minus 4. So minus 2 minus 1 will be minus 3. Minus 1 minus 1 will be minus 2. So 0 minus 1 will be minus 1. So this is my signal. Okay. So what I'm going to do, I'm just going to check whether there is any overlap between these two signals. Okay. Let me check it here. Starting from minus 4, I don't have a signal here at minus 4. Starting from minus 3, I don't have a signal here at minus 3. At minus 2, I don't have a signal here at minus 2. At minus 1, I have a signal here and I have a signal here. So there is an overlap between the graph. I have found the overlap. So at the point of overlap, I'm just going to check what is the amplitude. The amplitude here is 1 and the amplitude here is 1. So 1 into 1 will be equal to 1. So at the point of y is equal to y of minus 1, the value of the signal is going to be 1. Next, I'm going to increment the index values. Okay. So next, if I have to increment the values, previously I have substituted n is equal to minus 1, right? So now if I increment the value, I'm substituting n is equal to 0 here. What happens? Y of 0 is equal to summation k, that is equal to minus infinity to plus infinity, x of k into h of k, which is the actual signal, which is the time shifted actual signal of h of k, right? So what happens here? I'll have the signal at minus 3, minus 2, minus 1 and 0. But in case of x of k, I have the signal which is 1, 4, 3, 2 at the point minus 1, 0, 1 and 2. Right? So I have the signal which is at minus 1 and here also I have the signal which is at minus 1. Right? So there is an overlap between the signals. And I have to check the other points also. If I check the other points which is 0, I have a signal at 0, I have a signal at 1. Right? Other than that, do you have any overlap? Minus 3 and minus 2, I don't have a signal. And here minus 1 and plus 2, I don't have a signal. So at the point of minus 1, I have the amplitude which is 3. But here at the point of minus 1, I have the amplitude as 1. So 3 into 1 will give me 3. Okay. And again at the point of the time period 0, I have the amplitude here as 1. At the time period 0, I have the amplitude as 4. So 4 into 1 will give me 4. So 3 plus 4, which is equal to 7. At all other points, I have the amplitude as 0 and I have the amplitude point only at minus 1 and 0. Right? Okay. Similarly, when I increment it to the next value, what happens here? Similarly, if I increment it to the next value, which is n is equal to 1, what I will have? So again, I'm going to shift the signal positive side by one step. So if I shift the signal positive step by one side, 0 will go to 1, minus 1 will go to 0, and minus 2 plus 1 will become minus 1, minus 3 plus 1 will become minus 2. This is the resulting signal which I'll be obtaining, right? So I've shifted one signal and another one signal is going to be my original version, right? So my original version is at minus 1, 0, 1, 2. My next work is to check if there is any overlap. So I have signal at minus 1. Here also I have signal at minus 1. Here I have signal at 0. Here also I have signal at 0. Here I have signal at 1 and here also I have signal at 1, right? So I have 3 overlaps. Next I have to check the amplitude. So 2 and 1. So 2 into 1 will give me 2. And again I have an amplitude 3. Here I have amplitude 4. So 3 into 4 will give me 4 threes are 12, right? And here I have overlap at the point 1. So the amplitude here is 3 and the amplitude here is 1. So 3 into 1 will give me 3. So at other points I don't have amplitude here and here. So 1 into 2 will give me 2. 4 threes are 12. So 2 plus 12 will give me 14. 14 plus 3 will give me 17. So 17 will be my value at y1. Next, if I increment it another time, so here the index value will become y of 2. So summation k, that is equal to minus infinity to plus infinity. Again, I am going to shift this signal to positive side by one step. So 1 plus 1 will become 2, 0 plus 1 will become 1, minus 1 plus 1 will become 0, minus 2 plus 1 will become minus 1. So this will be the resulting signal after I shifted 1 times. So next step is to find if there is any overlap between these 2 points. I have signal at minus 1. Here also I have signal at minus 1. Here I have signal at 0. Here also I have signal at 0. Here I have signal at 1. Here also I have signal at 1. Here I have signal at 2 and here also I have signal at 2. So next I have to multiply the amplitude. So 1 into 1, 2 into 4, 3 into 3 plus 1 into 2. So the resulting signal will be 20. So similar to that, you're going to increment the values to n is equal to 3 and n is equal to 4 and n is equal to 5. Okay, you just work out these things and check whether you are also obtaining the answer, which is 16 for y of 3, y of 4 is 7 and y of 5 as 2. So the output of the signal, which is the convoluted version, as I've stated earlier, when both the signals are of length 4, so 4 plus 4, which is equal to 8, minus 1 will be the output convoluted signal's length. Here you can check the output convoluted signal length is also 7, right? So the output convoluted signal will be y of n is equal to 1, 7, 17, 20, 16, 7, 2 will be your output sequence length. Okay, the reason why I have marked arrow here is that because the signal here is at the point 0 and this is at the value minus 1 and these all is going to be at the point of 1, 2, 3, 4 and 5. Hope you have got a clear idea how you should solve the graphical method of convolution. So this is going to be your practice problem. You can try solving this problem.